Now we are going to deal with circular motion on level road, banking of tracks, maximum possible speed, up and down the incline, and equation of motion. Let me draw a circular path this way, and this is my vehicle. The point where it touches it here and here. So I got a normal reaction in this sense, N1, and I have N1. And I have one more here in this sense, N2. And by vector addition, this 2 becomes N. Now, the first wheel will give rise to a frictional force F1. The second one will give rise to a frictional force F2. Now, by vector addition, N is N1 plus N2. In order, the vehicle, uh, vehicle does not slip, does not slip, or I can say stays on the road, or stays on the road. Either of the two I can say stays on the road, on the road. Yes. Wait a minute. My pen just slipped off. Road. The thing is that F1 plus F2 must be greater than equal to the centripetal force. Must be greater than equal to centripetal force. This is the centripetal force. Now, what is F1? F1 is mu n1, sorry, and F2 is mu n2. Just put the values of this and this in this equation. Now, what you get is, let's scroll it down a bit. Yes, and then what I get is mu n1 plus mu n2 is greater than equal to mv square by r. You take mu common, n1 plus n2, and you have this is greater than equal to mv square by r. Now you see one thing. This n is, if you see this figure again, this n is actually balances the weight of the car or the vehicle, whatever you see. So n is basically n1 plus n2, and which is basically equal to mg. This equation is going to play the very important role for me. Now what I'll do is that I will put this equation. Wait a minute. Yes, I'll put this equation here. I'll use this here. Now see what happens is mu mg is greater than equal to mv square by r. This m cancels out. This equation now can be written as v square by r is less than equal to, sorry, I cancelled the wrong one. Sorry, the mistake, I cancelled the wrong one. This m would have been cancelled. Then this would have been, this would be mu g. So you have v square is less than equal to, you have v square, less than equal to mu, let me, just a minute, mu rg. So this is the, for the minimum speed, this is the, so the maximum speed that it can take is the maximum speed. See, the velocity has to be less than this quantity. I mean to say, velocity must be less than under root of mu rg. The maximum possible speed, maximum, wait a minute, sorry. Yes, the maximum possible speed, possible speed for the vehicle is v is max is equal to, now this will become equal to under root of mu rg. This is what you need for this expression. Now we will talk about in the next, now we will go, now let's see, we will see the next topic I think I will have to take over is banking of tracks. I'll take this topic now, banking of tracks. Now you people must have seen in certain places when you go to some hilly area or wherever, or even in these plains, wherever there is a turn in the track, some part of this is lifted in this sense. It's lifted in this sense, and this goes like this, somewhat like this. So this is called banking. This angle, which this road has been lifted up, is called banking. This angle is what we need to find. This is what is called banking of tracks. Now let's write the heading: banking of tracks. Now tracks, Whenever the road, or even you've seen while going to a place, by in this railways also, they, in some places they lift the level track in some, in this manner. They lift it up. It turns like this. This angle is called the banking, angle of banking. So let's try to find it out. Now let's draw the figure very carefully. This is the angle of banking. This is the horizontal. This is theta. This theta has nothing to do with that angle of repose and angle of this. This is different. This is different. Don't confuse with that, because I have only few alpha 23 Greek alphabets, and this is the angle of banking. Now see, I my body is here. It is mg. This is here. This is now in this direction. This has to be theta. I have told you in a number of times. This is n. Now this is mg. This is now your mg cos theta, of course. Now this side is your, this side I mean to say. Wait a minute. Let me draw the picture clearly. The whole thing went off. No problem. This way. This way. Now, this is your mg sine theta component. You have already know about this. Now, do one thing. I'll changing the color. Now, see, I'll draw an axis in this direction. I'll draw this axis in this direction. Now, see very carefully what happens. This is theta. This angle is again theta, vertically opposite angle. I hope you're getting it. This angle is theta. This angle is, is 90 minus theta. And this, again, this is now theta. This is now theta because this and this are at right angle. Now, therefore, this angle is again a theta here, vertically opposite. This is just a geometry, nothing more than that. Now, do one thing. You resolve this n. You resolve this n in two forms. N cos theta in this direction, and n sine theta in this direction. N sine theta in this direction. Now, in order to make the body on the surface so that there is no slipping, the centripetal force must act in this direction. Mv square r must act in this direction in order to stop the body from slipping from slipping and going off the track. This is the point. Now what happens is that I just have to equate this equations, and my job is done. Let me, yes, it going, yes, now it is okay. Now see, this n cos component will balance this. So n cos theta is equal to mg, and this n sine theta will balance this because there is no acceleration. N sine theta would balance this mv square by r. Now do one thing, divide this equation by this equation. So what you get is n sine theta upon n cos theta is equal to mv square by r, and into here this is mg. This is not a dot, this is not a dot or cross, just normal multiplication, mg. This n cancels out with this n. This n cancels out with this. So your angle of the banking of the track, that is tan theta, comes out to be v square by rg. So your tan theta comes out, theta is the angle of banking. Theta is angle of banking. This is important. Do not confuse this theta with that angle of friction and all that. This is totally different. This is angle of banking. Because we have only a few Greek alphabets, 23, and we have so many symbols, so we have to use the same symbol again and again. So there is no need to confuse about it. Now, the topic that I would like to take over is, now this is the topic I'm going to take over, that is maximum possible speed up and down the incline. This is important, very, very important for your examination point of view. Even this is important. This has been asked. This angle of banking has been asked. I don't remember which year, but it has been asked. Now see one thing very clearly. Now what we'll do is that I'll write down the heading. Wait, let me write down the heading. Let me write down the heading. Maximum possible speed. First, I'll take the down the incline, so it does not slip down the incline. Maximum maximum possible speed, possible speed, so that maximum possible speed, I'm taking in short. This is vehicle does not slip down. Vehicle does not slip, does not slip down. I'm using the down one first. Remember this down one, down one. Now what I'll do is that I'll make a figure for you all. Wait, let me hide this. I don't need it anymore. Now see, yes. Now let me draw the figure very, very neatly so that you understand. Let me make it big for you. Yes. Okay. This is the theta, angle of banking, whatever you want to call it. This is your body. This is your mg part. This is your theta. The normal reaction is in this sense. This is your mg cos theta, undoubtedly. Now there is a since the body does not slip down, there will be a friction in this sense. Slip down, friction in this sense. This will be now. This is a friction in this sense. If you want to write, you can write m2. Wait, m2 g sine theta here, no problem. And here is your normal reaction. What I'll do is that now I'll draw this figure. Wait, let me take this color. Let me take this color. Let me take this color. Now you know that this angle is already theta. This angle is vertically opposite. This whole is 90. This is 90 minus theta. So this comes out to be theta. This comes out to be theta. And if this comes out to be theta, then this is also theta, vertically opposite. Now the f is in this place. So f you will resolve as f cos theta. You will have two things. F, I have to rub it. Wait, I have to rub this. Yes. Now I'll take f as f cos theta in this sense. Another, this normal reaction will, I will resolve this normal in this sense. This will be n sine theta. Let me write n sine theta in this sense. Now n cos theta would be in this sense. N cos theta would be in this sense. And this f is now going to be resolved again in this sense. F sine theta. Let me make you understand the figure again. This figure is very, very important. See, I'm redrawing the whole stuff. Once this is clear, the whole picture is clear. See, I'm making it big, very big. Now, see, I have drawn this here. This is your mg, no doubt. Now, this is your theta, no doubt there should be. I have drawn a normal in this sense, no problem. This has to be theta, you know why. This is 90. This is 90 minus, this is 90 minus theta. This portion is always 90 minus theta, always. So this is your mg cos theta. Now this is your normal. Now do one thing. This is your, in order the body does not slip down, I put a friction in this sense. I'll put a friction in this sense. This is my normal. What I'll do is that I'll draw this line and this line perpendicular to each other. These two blue lines are perpendicular to each other. This line is this line only, blue line. Now see, now this is theta. This has to be theta because it is vertically opposite. This whole is 90. This is 90. This blue line and blue line. So therefore this has to be theta because 90 and 90 minus theta. That is 90 minus theta would give me theta. And this theta is this theta. I hope you now understood. Now see, now here you can write this. Wait a minute. Let me write. Though this component is not necessary for the sake of completeness, mg sine theta component, though I don't need it anymore. Now do one thing. Resolve this n. Resolve this n here. This will become n cos theta. Resolve this n here. Let me extend this blue line. Let me extend this blue line here. Let me draw the partition so that you don't confuse the two diagrams. Now this is n sine theta. I hope you have no confusion here. Now this f component will now be resolved in this sense. This will be f cos theta and this will be f sine theta. Now I hope this figure is now clear. Alright, and now I will no more explain this because now I have explained it in great details, this complete figure. Now what I'll do is that I'll erase this figure. No need of this figure. What I'll do is that I'll just erase this figure. I'll just erase this figure. Wait a minute. I'll just erase this figure. I'll just erase this figure and I'll use the space to write down the equations. Now you see how I write down the equations. Now you see how I write down the equations. Now, see one thing. These two forces will balance will give rise to centripetal force. So now you see what n cos theta will give. This will be equal to this and this. There is no horizontal motion or vertical motion. So the first equation is n cos theta is equal to, they are in the same direction, f sine theta plus mg, no problem. Now, this surface has friction. It has a coefficient of friction mu. Let us say coefficient of friction mu is there on the surface. No problem. Now, this two, that is n sine theta plus f cos theta, n sine theta plus n sine theta plus f cos theta plus f cos theta will give rise to centripetal force mv square by r. No problem about it. I hope you should have no problem about it. Here I can write mg as, listen, now f is what? What is f? F is nothing but mu n. Now just substitute the in place of f and f. Now n cos theta equal to mu n sine theta plus mg. Let it be here. And n sine theta plus mu n cos theta equal to mv square by r. Right? Now, yes, you have these two equations. Now, since you have got these two equations, now you have something. See, I hope I'm not making a mistake. F, yes, F is in this sense. And I have, yes, now let me bring this thing here. Let me write down the equations below. Yes, now you see, I write mg equal to, I take n common, I take cos theta also common. No, I'll do it in one, no, not in one step, I'll do it in two steps. Wait, I'll write n cos theta minus mu n sine theta. See, minus mu n sine theta. So what I'll do is that I'll now take this mg here, I'll take n out, I'll have cos theta minus mu sine theta. Now I will do is that take cos theta out. See, n cos theta. So this will be 1 minus mu sine theta upon cos theta. Now if you multiply this cos theta inside here, you will get back this expression. So you can check it yourself. Now this becomes very, very important equation. Mg equal to n cos theta 1 minus mu tan theta. This is the angle of banking tan theta. Do not confuse with that angle of repose and all that stuff. Now you have the next equation. This is my most important equation. The next equation is this equation, which I need. Now see, mv square by r. What I'm doing is that I'm taking n common, and then you have mu cos theta, and then you have your plus n common sine theta. Again, the same way I'm taking cos theta out. I'll take cos theta out is equal to n cos theta mu plus sine theta by cos theta. And then I'll get this as mv square by r is equal to n cos theta. Then I'll have mu plus sine upon cos is tan theta. This is my equation number 1 and this is my equation number 2. Now I'll do is that I'll divide this equation 2 by equation 1. See what happens if I do this. If I divide equation 2 by divide equation 2 by equation 1. Equation 1. Now see what happens. You have mv square by r. This mg comes here. Mg. This is equal to n cos theta. Then you have mu plus tan theta on the top. You have tan theta on the top. And then you have n cos theta 1 minus mu tan theta. Tan theta, they cancels out, they cancel out. Now what you have got with is v, and by the way, v square, I should have done one change here. Wait, let me do that change. See, this component should be more so that there is no slipping. This component should be more so that there is no slipping. So I should, okay, no problem. If I just have to see the banking angle, I don't have to see maximum speed and all that. You can leave that. V square by Rg is equal to mu plus tan theta, and 1 minus mu tan theta, and you cross multiply Rg on the other side. So what you get is V equal to under root of Rg mu plus tan theta upon 1 minus mu tan theta. I hope you didn't have any problem understanding this. Now this was, which it was down the slope. Now I will take up the slope. I'll take up the slope now. No, wait a minute, let me write it little clearly. And this line has to be deleted. Wait a minute, let me write it clearly. This is tan theta. They both are tan theta and tan theta. Now, let me draw the line and let me do up the plane. Now, the figure remains the same. See, this figure will, if I copy this figure, one thing will change from this figure. You see, if I copy this whole figure till here, wait a minute, if I copy it, if I copy this figure, something will change. I'll show you what will change. Let me put it here. Let me put it here. Wait a minute. Let me put it somewhere here. Wait a minute. Wait. Yes. Here, let me again select the whole picture. Wait a minute. Let me select the whole thing. Let me bring it more here. Yes. Yes. Now I have got everything. Now you see, now something will change in this picture because we are now dealing with up the plane. Earlier it was down the plane. Now we are dealing with up the plane. Up the plane. Up the plane. So now what will change? This direction of friction will simply go. This direction of friction will go. Nothing else will go. Let me write it here clearly. Wait. This mg. Now the friction direction will be in this direction because I have to stop it from slipping, and this angle is theta as usual. Nothing else will change in this figure. And now one more thing will change, that this component will no more be here, and this component will now vanish from here. This line, okay, this now only what will be left will be mg here. Now you will have this will remain as n sine theta only. There is no change in this. Let me write with the blue color only. There is no change on this. This will be n sine theta only. This will be n cos theta as written in the green color. Now extra will come now. Here it will be f cos theta, and here it will be another one will come now, f sine theta. This much change only will take place. Nothing else. The diagram and every relation between the angles and everything remains the same. Now see how the equations are to be written very clearly. See, now you will see how the equations are written very, very clearly. Now you will see your f, let me write with other color. Wait, let me write the black. Use f sine theta, this component, f sine theta plus n cos theta, this green component, n cos theta will balance the weight, number one point. Now these two are opposite, so n sine theta and then minus f cos theta would be equal to mv square by r. Now as usual you write f equal to mu n, and exact same procedure what you have used earlier you will have to use here. You will have to write mu n sine theta plus n cos theta equal to mg. You take the n out and write like this, mg equal to, you take n out, then you have mu sine theta plus cos theta, and then you take cos theta out, n cos theta, then you have mu sine theta upon cos theta plus 1. So now you have your mg is equal to n cos theta mu tan theta, sine upon cos is tan theta plus 1. This is the point here. Now see what will happen is that Now you have this equation as number one equation. You have this as number one equation. Now from this above one, I'm talking about this one. I'm talking about this one. Now again, n sine theta minus f cos theta. Let us write n sine theta minus f cos theta. So n sine theta minus f is mu n cos theta will give rise to mv square by r. I take n common. Mv square by r is equal to, I take n common, then I write sine theta minus mu cos theta, and then I take the cos theta out. I take cos theta out, n cos theta, then I'll get sine theta upon cos theta minus mu. Now you will get this minus mu here, and then you will see mv square by r is equal to n cos theta, and you have tan theta. Wait, let me rewrite. Tan theta minus mu. So this you will get again. Now, what you will do, this equation is going to become your equation number 2. This equation is 2. Now just see these two equations. Just these two equations, nothing more. You need to see this equation number 1 and you need to see this equation number 2. That's all. Divide 2 by 1. So, or 1 by 2, whatever you want to say. That is, yes, you have. Yes, you divide mv square by r into mg. You have this n cos theta on the top, tan, your 2 is on the top, equation 2. Tan theta minus mu upon n cos theta, and you have mu tan theta plus 1. Now this and this will cancel out, this and this will cancel out. You will get, wait, let me rewrite this clearly. This is square. Oh, wait a minute. This is square. Now you have, see, you have v square by rg equal to tan theta minus mu upon mu tan theta plus 1. And then from here you get v is under root of rg, take the bracket, tan theta minus mu and upon mu tan theta plus 1. So with this, I did up and down the incline. Now I think I am now left with the equations of motion. These are very, very important. Wait, let me scroll up a little bit. Wait, yes, let me scroll up. Yes, here it is. Now the equations of motion, we will do it. The last part of this, and then we'll do some problems. See, I hope you have been able to see the difference. Now see this difference. Up the incline, there is a minus on the top and a plus on the down. Now let's see what did we see there? What did we see there? We saw, yes, here it is. Plus on the top and a minus on the down. This is the only change. So you have to be very careful what they have asked. They have asked up the plane or down the plane. That's very important. And of course, you can write this point that what I said orally, you can write down this point. The weight is acting vertically downward. Then the normal reaction is acting at an angle theta. You can see, wait, in both the pictures. In both the pictures, you can see in this picture, the normal is acting at an angle theta to the vertical. Here also, the normal is acting at an angle theta to the vertical. So these all things what I written. Friction force is inclined. See, in this case, the friction is inclined downward. Friction is inclined downward here. You can see this. In this, what is the only difference? The friction is inclined upward. This is the only difference. The rest all is same. The iron is in this direction making an angle this. Only this friction is changing the whole stuff. You can see it is here coming out to be this because of friction down, and because of friction up you are seeing this. So this is the total difference between the two expressions just because of one simple component. Now you will see the equations of motion. Very simple. Though you have done it in class 9 in a different manner, I'll use derivatives because we have done derivatives already. We have done derivatives already in lesson 3 of our video. So we will do it with derivative. See, the first is, we know F is equal to ma. Forget about the vectors. I'm not interested anymore. So this is m dv dt. M dv dt is equal to ma. You can cancel this. So we get, so what we get is, we get dv dt is equal to A. Now dv is equal to A dt. I'm no more going to explain you why this is. Now this is the initial, I write u, the final I write v, and this is initial time is 0, final time is t. Now what I do is integrate. I know this is 1, v to the power of 0 is 1. So I'll write v, I'll write the lower limit and the upper limit, and here also a t. I'll write the lower limit and the upper limit. Now from here I'll get upper limit minus lower limit is equal to A upper limit minus lower limit, and I'll get V minus U is equal to AT, my first equation of motion. My first, oh, sorry, just a minute. This got, yes. My first equation of motion I'll get in this manner. My first equation of motion. This is my first equation of motion. Now from this, I'll try to get my second equation. See, what we have got is, let me drag it up more, no problem. Yes, now we have got this. Now you write V equal to U plus AT. This U goes that side. Now V can be written as ds dt, and this can be written as U plus AT. This is T, AT. So what you take is that now ds is equal to U dt plus AT dt. Now you take the integration from 0 to s, you take the integration from 0 to t, you take the integration from 0 to t. Now this will be s and this will be 0, and let us call it s only, no problem. You know why this integration is coming out to be s. I've told you number of times. Now you can do it on your own. Ut, now 0 to t. In my earlier videos, you check the third lesson of integration and differentiation, you will be able to understand this. If you have still not understood this, then it is a t square by 2. You will take the lower limit and the upper limit. Now you will put the values. Wait, now you will put the values. S minus 0 is equal to ut minus 0 plus a by 2 you take out t square minus 0 square. Now you have s equal to ut plus half at square. This is your second equation of motion. Now let us see the third equation of motion. Let me write this, draw this box. This is the second equation of motion. And now we have the third equation of motion. Now we have the third equation of motion. That is, wait, I don't know from where it is thinking, sorry. Now we will do the third equation of motion. We already have, see, I wrote F is equal to MA, didn't I? Now F is M. This is, we have this as M, M dVdt was your C. Let me not write it in this manner. It will be a bit confusing. Wait, you know already. Let's take this straight away, easier approach. Wait, we know V as acceleration has three formulas. I have already told you in my other video, but still I'm recapping it here. A dv dt, A acceleration is dv dt. The next is double derivative of distance with respect to time. The other is v dv v by ds. I'll take this and this. See what happens. V dv by ds equal to a. From this I'll write v dv is equal to a ds, and now I'll integrate from 0 to s, and I'll integrate it from initial to final. V is final my, and this is my initial. This is the variable v. So see, now this will become v square by 2. Then you have your lower limit and upper limit. Now this is your a ds. Sorry, wait a minute. This is now s. This is now s, and you have 0 to s, and then you put the upper limit v square by 2 minus u square by 2. You have a s minus 0. Now you have this equation. You have v square minus u square equal to 2as. This is your third equation. This is your third equation. Now you all know how to get the three equations